We're going to start doing cross sections, volumes of cross sections. So this is like my attempt to show you visually what's happening. No, okay. There's your regular, like, two-dimensional. Now we're going to make it three-dimensional, maybe. Yeah, okay. This is way harder than I thought it was going to be. All right. So then they're going to build shapes on top of it. So this would be a square. So the distance between these two curves, the blue and the red curve, will be the base of a square. So I could go like, I'll put it here, let's say, and you can see, like, I'm just gonna add squares to it. There's actually an infinite number of squares. I'll move this all the way to the side. We can see like the whole shape. There are squares on top of every section. So all of these little things in there are squares, and then when you make a bunch of them, you get a three-dimensional figure. Here's what it would look like if it were, wait, I can do both? That's terrifying. Let's just do equilateral triangle. So there's one, two, you can just see how they're kind of building on top of, and then it makes like a three-dimensional shape. Semicircles, same thing, there's like one, and then, every single strip that goes between those two curves is going to be the base of its own semicircle, and so you get like a three-dimensional figure at the end. So that's what we're trying to find. I'm going to pass out another worksheet. I don't love the way the guy does it. Right. No, right. Alright, we probably need to review some area formulas first. I could be wrong, but I would flip it over like to the back. I know it seems ridiculous, but well, kinda. See, you just make fun of geometry all the time. What's the area of a square? It's not supposed to be a trick question. Side squared, length squared, base squared. What if I gave you the diagonal? Yeah, so like, I'm telling you there's a square with a diagonal of 10, find the area. Anybody? The answer would be 50. But you said square root.
Yeah.
So you're really good credit.
No, yeah, I'm right, because square root of 50, I'm right. Square root of 50 is each side. Square root of 50 times square root of 50 is 50.
You found the side.
Yeah.
Okay. It's 1/2 times the diagonal squared. I probably should make you guys like derive that and figure it out, but that's okay. Isosceles right triangle. So that's just 1/2 base times height, but if it's isosceles, you could say it's 1/2 base squared. Because if it's isosceles, the baseline is the same, Equilateral triangle. Anybody? So I give you like, here's an equilateral triangle with a side of 6. Every side is 6. Can you find it? Should I just tell you? It's the square root of 3. It's also on the board. Nobody even looked at it. It's the square root of 3 over 4 times the length of the side squared. Yeah, we could like prove that and figure it out, but it's not that big. Circle pi r squared or pi times the diameter over 2 squared, right? A little more comfortable with that one. And then semicircle. So 1/2 pi r squared. Or, and this is the one I really want to show you, or it'd be 1/2 times pi times d over 2 squared. Like those are the same thing, right? Because I'm just putting d over 2 in place of r. I am trying to show you something that you don't know here, that you may not realize. So very often they will write this a different way, and they would write it like this. And I just want you to understand that is the same thing. Because that divided by 2 on the bottom gets squared, right? So it's really a 4 on the bottom, times this 2 on the bottom over here, so then they'll pull that out and make it like 1/8. Okay, so for all of these, there's only one variable. And what goes in that slot, so if I give you a square, it's length squared, and the length of every square is top minus bottom. If I give you the diagonal is top minus bottom, and you 1/2 times diagonal squared. If I tell you it's isosceles right, the base is top minus bottom. Equilateral triangle, the length is top minus bottom. Like, whatever the distance is between the two curves I give you becomes the length or the radius or the base or whatever. So you're really just plugging top minus bottom into variables here. So let's look at some examples. Let's number 1. So cross sections perpendicular to the x-axis. That tells us we're going to be in terms of x. So I'm going to have the left, the right, and then I'm going to integrate the area times dx. Everything's going to be an x value. And the integral of area is volume. So perpendicular to the x-axis are equilateral triangles. I want you guys to try to draw these, just so you kind of get an idea of like what it looks like. Also, kind of so I can walk around and laugh at each other. So it'd be something like, I don't even think this is really that great, but if those are equilateral, it's something like that. Left and right boundaries are -6 and 6, right? Area of an equilateral triangle is the square root of 3 over 4 times the sine squared. And then the length of every side is this distance, which is top minus bottom. You just do the top equation minus the bottom equation. So this in here would go top minus bottom, which is this guy minus 0. So it's really just negative x squared over 9 plus 4. And that's the setup, and if you type that in, you would get the volume of that shape that it's created. But today we're doing all the shapes in terms of x. Tomorrow we'll do them all on Wednesday, I guess. We'll do them all in terms of y. But then we'll start combining everything and review it. And we test like early next week probably. Questions on 1 there? What do you got?
It's like value of a square, like it is a square, right? Square, you take out half the squares. I mean,
I don't know what you're getting. On this problem or like in general?
in general,
Say it again.
like you have the. I don't know. Value of, like you have triangles and then you take out a square in the center.
Oh, it's like a geometry problem where I'd be like, here's this, find like the shaded area or something,
Yeah.
but like revolving it.
Yeah.
It's kind of cool, but we're not doing that. All right, second one. So perpendicular to the x-axis, that tells me I'm in terms of x. Obviously, you know, if I write in terms of x every time, I'm just trying to reinforce. of x, so we'll have dx. And the cross section, so that just means the distance between these two, are isosceles right triangles, which is actually what I think I drew number one. I don't know. I'm not the greatest artist here, but if you can imagine that being a right angle, you have a bunch of right triangles coming out like that. So the base is the cross section. So it's those two that are the same. And then what's our left and right bounds? -2 and 2. The area of an isosceles right triangle is 1/2 base squared. And how big is the base? So that's bottom, which is 4 minus x squared. Does that make sense what I'm showing you? Picking up what I'm putting down? Smell what I'm cooking? Let's look at number 6. That guy's a circle. Actually, let's do 10. 10's better. So, a couple things are happening here. One, we got cross sections perpendicular to the x. So we know we're in terms of x. The heights are twice that of the side. So the area of a rectangle is base times height, yes? They're telling me the heights are twice as big as the side. So they're doing like, they're calling the side the height. The height is going to be twice that of, they're calling the side the base, I guess. The height is going to be twice that of the base. So would you agree that I could do that? The height is going to be double the base, which would then make it, 2 base squared. If the height was quadruple the base, you would end up with 4b squared. If it was triple the base, you'd end up with 3b squared. So that's one issue, is just the area. The second issue, I got -6 to 6. You got rectangles where the heights are twice as big as the sides, so something like this is going to be like a big old side. That's not parallel at all, it doesn't look great, but hopefully you get the idea. But the issue for most people is where I'm supposed to do top minus bottom, right? Well, there's just one equation there. How do I do that? Well, if I took that equation and solved it for y, wouldn't there technically be 2 solutions? The positive and the negative root. So the positive root is this one, and the negative root is this one. So x squared plus y squared equals 36. So subtract x squared. So y squared equals 36 minus x squared. And then if you square root, if you solve that, you'll get plus or minus root of 36 minus x squared. And that's where your top and bottom come from. So this guy up here is where the y values are positive, so that's the square root of 36 minus x squared. And that guy down there, well now the y values are negative because we're below the axis. So now we get negative root 36 minus x. So I'm going to integrate the area. The area is 2 times every base squared. I left over in there. What's the base? In general. Top minus bottom. And so in this equation, it's just this minus this, right? I did not mean that. Root 36 minus x squared minus negative root 36 minus x squared. So you put plus, you put minus negative, you could actually if you really wanted to, that's 2 times 36 minus x squared. I would never do that on my own, but the multiple choice could match up with that. Just because root 36 minus x squared plus itself is 2 of those. But either of those are fine. I would definitely do that one. Why is there no pi in this? Like when we were revolving last week, there were pies. Why is there not a pi in this? Yeah, when you're revolving, you're making circles, right? We're not revolving anything here. I know the base is a circle, but we're just adding up a bunch of rectangles. So that's a common thing I'll see is people, like, you kind of get lost. When do I put the pi in front? When do I not? It's only when you're revolving because you're making a bunch of circles. How'd that one seem? Give me thumbs up, down, sideways. Flip me off, it's not going well. Did you actually?
Yes.
Jason just flipped me off. I told him to, so. Let's try, you guys try 15. I'm going to send you out of the office, flip me off. I'm going to delete the recording that shows that I told you to flip me off. Get you expelled.
Big brother. Yes.
You don't need a criminal lawyer. You need a criminal lawyer. Did you guys all see the Minecraft movie?
Oh, shit.
My son said he's 14, so the movie was bad, but the experience was really fun.
I like it as a part of the call.
That's kind of what he was saying.
Screaming and yelling at the
Yeah.
large screen. Yeah.
Oh, it was like too much.
Yeah. I went on Friday. It was like a good amount of fun. It wasn't excessive, but it was whenever Jack Black was in the games. Checking documents. It was an insane experience.
Isn't that one too? I was.
Steve, yeah, Flint and Steel.
So, I gotta get my two equations first. They only give me one, and I have to do a top minus a bottom, so I need two. So I'm gonna break it apart into the two positive and the negative square root of y. And then my left-hand boundary is -4, my right-hand boundary is 4. Perpendicular to x-axis, so that's dx. My isosceles right triangles, so that's 1/2 base times height. But if my isosceles, the baseline are the same. I did the same freaking thing. And then it's going to be top minus bottom. Here's how I'm going to fix this. Call that f of x and that g of x. And I have space to write f of x minus g of x. You probably just put like root 16 minus x squared there. Minus negative root 16 minus x. This is fine. This is valid. I only did it because I ran out of room, but you can do it. What's up? Someone said don't think of any question.
I said no.
That was just a question, though. You were just okay.
Yeah.
Question on this one? Alright, keep going. Answers are attached. They're on the back. You're just setting them up. Please don't work them out. I mean, I guess you can. And then, like, the way these present on the AP test is kind of what we'll start doing on Friday, because Wednesday we're going to do this with respect to y, which is really not that big. But then on the AP test, what it would look like is they'll give you a shape, like, say two equations, and then part A will be like, find the area between them. Part B would be revolving around this. Part C would be find the volume of the cross section. So it kind of just runs through the last few things we've done. They'll give you a shape in the last few things that you like a bunch of things with it. So that's what we'll start practicing Friday, and then get ready for your tests probably like Tuesday or Wednesday next week. Where are you testing this?
was waiting for one of that. It's not, even though it was fine. Which is crazy to me. It's just like, I had been scared of getting so many pieces of paper that thing.
Maybe garage doors. This will make you never either check them every time or never drink. I was a kid, drank Coke in my mouth.
I've seen pictures of dogs that got like the inside of
They
their
look
mouth something
funny.
that just they're like
I like that. I like that.
I just cartoon television does. Tracks.
No, I used to like have to sit outside.
You ever seen those cups? The cup tops where you can close them. You put it on and get Coke. You like open it down, it drinks,
yeah.
close it.
How do you deal with going to happens?
I don't do it well.
Yeah.
It's really awful.
I mean, the last few times they were just like everywhere.
I get really good.
The one thing that I
You're still scared.
I mean, it's definitely
Are
a
you?
lot better, but like, no, like I genuinely would not like.
Oh, I get it.
My parents would tell me to go gardening, and I would wait until like 10 p.m. to go do it because I knew the bees were going to be out. I was like, I'll be good with it.
I like with snakes. But snakes are a lot easier to avoid than bees.
Snakes are awesome.
Snakes are.
I think it hates. My
I got to
uncle
hold a
hates.
snake.
Because it slithers and you don't know where it's gonna go and you can control it. I don't know.
My uncle he's terrified of snakes too. He used to live by a highway where they would like migrate or something. I don't know. And so like every
Like
spring.
in mass.
Yes. And my dad told me one time he got like so like terrified, he just took a gun and he went out there and just started shooting.
It's pretty hard to shoot with it.
Yeah, he's terrified, kind of stupid.
My worst thing is jumping spiders. Like a partridge, like big spiders.
Yeah, big spiders are fine. I'm with you. Big spiders are
That's
great.
'cause
The
they're more
tiny ones are bad
predictable.
ones.
That's the spiders.
We're elephant
I
posting
have
right
so
now.
many.
Like how you're
Fears aren't
saying
like,
mice.
those kind of fears aren't rational, right? There's more to it than just that.
Yeah.
Yes, phobias are supposed to be rational.
Well,
Well, not irrational, but like,
sort of rational.
yeah.
Because you're way more afraid of things than you should be. Realistically, I'm way more afraid of snakes than I am realistically. So it's not really. Like rationally, I know it shouldn't be, but
No, that's how I am. I'm like, I know they probably feel this, especially like honeybees.
like a garden snake. But I would still, if one like crawled through here, I would find a job. I'm done.
Nice.
Yeah, like with jumping spiders, though, they like disappear. Scares me so much.
That is, I can see that.
It's like, you know it's somewhere. You know it's somewhere nearby. You have no idea if it's on you, if it's somewhere
I think we should be
else.
more afraid of people, other people. Like statistically, other people are more likely to kill us than any other people.
Well, I also had that.
I'm also kind of afraid of people.
Yeah, no, that's true. Some people are like, people can't do that.
I wish I could have no consequences when I was driving because I would like honk all the time. But I'm always afraid that I would get like shot.
Shot, yeah. It's the number one thought taking on the issue.
And there's no advantage to initiating confrontation, really.
Yeah, but it's fun because it goes honk. I don't know. It makes a noise.
But my car used to.
Just sit in your driveway and just honk.
You still set the horn as a fart.
Yeah, yeah.
They took that away.
Oh,
I didn't know why, because I
They
like,
hate joy.
pull up to an intersection, someone's got in front of me. To the horn and it just farted.
I don't know who it was, but
Never
someone
stopped.
trade one in your car.
My uncle did that. He also has floodlights in the back, so if someone's annoying, he just.
Oh.
Dude, that's
He's ran people off the road for him. He's
some people are
he's
stupid.
crazy.
That's better than a brake check.
Yeah.
Someone's.
Well, one of the people he ran
Blinded
off the road was because they were brake checking him. So,
But he could use the floodlights.
well, he just got him from.
So what do you, so if there's someone in front of him,
Oh, he can
He's a
get
big
past.
ass truck. He can pass whoever he wants.
I don't think this man is accepting defeat.
No.
What? Lights faded too. Maybe.
LED headlights are to minimize
It makes me
there, Bryce. And I was like, oh my god, that's way worse.
I do that to people like a good like 2 times every time I drive by. And I ended up like, okay,
I thought that's how bad it was with the Bryce, and then they actually turned with
I'm
the
just
Bryce.
blind and I cannot tell how
I
bright
actually
anyone's
almost-
brights are that bright.
Like, if there's a deer right behind them, there's just nothing. I just can't see it. All I can see is like.
Once someone had their LED like brights moving on and I flashed them and they did not turn them
Yeah.
off and they kept going and I just feeling it was just complete white.
Yeah.
And I was just like,
Classic right there. In the process, the colors change time. So that was a full deep red. Deep red run. Yeah.
Oh, so I had to order one. It was supposed to come in yesterday. So I'd be like, coming to school and I have, nope, delayed.
Hate that.
At least it was like 12 months or something.
Still, like the delay is just like just feels like unfair.